Hi, I'm Helen. I'm from the Android machine learning platform team in Google, and welcome to my talk today. Today, I will do a short presentation first, and then we will do some live coding to show you how to use TensorFlow Lite with Google Play services. Then we will have a Q&A at the end. So if you have any questions, please put them in during my talk. So first, what is TensorFlow Lite? The goal of TensorFlow Lite is to provide the execution environment for running models on mobile and edge devices quickly and efficiently. It is an on-device machine learning solution that is based on TensorFlow. On-device machine learning means it is different from the server-side hosting in the sense that models are often bundled into your app or your device, and the model inference also happens on device. This is an offline process, which makes the machine learning feature works even when the internet connection is not available and your device is offline. The benefit is that it saves the cost of server-side hosting. It also reduces the round-trip latency of talking to the server, and it made real-time processing possible. The special challenge about mobile and edge devices is they are often with limited memory and computational power. In order to achieve that goal, TensorFlow Lite provides a set of tools for you to both optimizing and deploying your model. It includes a mobile library that provides high-performance machine learning runtime that is optimized for on-device use case. It also tries to achieve high performance to deliver high-performance machine learning features. It has a offline optimization tools to help you make your model work better in this scenario. It also has on-device hardware acceleration at inference time. It supports multiple platforms. It supports Android, iOS, embedded Linux, and microcontrollers. So TensorFlow Lite model is a bit different from the TensorFlow model you might already seen. It is represented in a special portable format called flat buffer, and usually it ends with .tflite extension. So this format is to make the model smaller, and it gives faster inference because model data can be directly accessed without packing and unpacking the model on device. There are two ways that you can get a TF-Lite model. If you already have a TensorFlow model that you're very happy with, you can use the provided conversion tool to convert a TensorFlow model to a TensorFlow Lite model. And you can find the tool on the website. And during the conversion process, you can also apply different optimization techniques. You might want to optimize a TensorFlow Lite model so that it is smaller in size and it runs faster. The optimization technique, such as quantization, it can help you to reduce the model size with minimal or no accuracy loss. You also have the option to optimize the model for a specific type of accelerators. For example, if you want a model to only run on GPU, you can optimize so that it runs faster on GPU. There is some limitation that not all of the TensorFlow operators are supported by TensorFlow. During the conversion process, it will suggest to you what operators are not compatible and what be a good way to resolve that issue. Sometimes operators are not supported because they have performance limitation on devices. And another way to get a model is you can use the pre-trained TensorFlow Lite model provided on the device. We have built solutions to common problems. If you're an app developer, you often need to solve image classification, object detection, pose estimation, and question answering, etc. We have built solutions to these scenarios, and you can find both the model and the end-to-end examples on the website. If there are some cases you want to optimize for, you can also start with this existed model and then maybe optimize with your own training data and deploy the version that you're happy with. If you're an Android developer, we would suggest you to use the custom machine learning stack for Android apps. So the goal of this effort is to solve the production issue of machine learning features. Once you have successfully built a very high performance machine learning feature, it is also a challenge to deploy those features across different types of Android devices and different customization of Android systems. So we want to provide a coherent platform to help you with that issue. We're building toolings to help you gain insight of whether your model will be compatible with the underlying system so that you can focus to build the machine learning features and worry less about the production issue of these features. It is Google's opinionated way to run high-performance machine learning on Android. And this custom machine learning stack is provided through Google Play services. Currently, it has two parts. The first part is a TensorFlow Lite machine learning runtime that would let you run the model. And then the second part is the TensorFlow Lite delegate library. So what is a delegate? By default, your machine learning model would be running on CPU on the mobile and edge devices. But we all know that modern phones, they sometimes have device hardware that are better for running heavy machine learning operators. For example, if you have GPU and you're doing image processing related operations, you might want to run them on GPU because it is faster to run on GPU rather than on CPU. But in order to do that, you would need to write a lot of custom code against the lower level APIs provided by these underlying hardwares. So TF-Lite delegates acts as a bridge between the TensorFlow Lite runtime and the underneath hardware device hardwares so that you can easily move your model from running on CPU to running on a different hardware as you want. It is a cross-platform concept that it is available for multiple platforms. For Android specifically, currently we provide the GPU delegate and an API delegate. And with these two delegates, you can move your model from CPU to GPU and DSP and TPU very easily through just TensorFlow settings. So previously, if you were having TensorFlow Lite bundled into your own app from the org.tensorflow SDK, you would have the TensorFlow Lite runtime SDK, and you might also have the GPU delegate SDK if you want to use GPU. These two SDKs are bundled into your own app. And even if not all of your users' device support running machine learning on GPU, but because it's very hard to tell at build time whether it will be supported or not, you would have to bundle in that library into your own app. And you will also need to manage the versioning of those SDKs. And if you choose to use TensorFlow Lite with Google Play services, you can, instead of bundling those two SDKs, you can request them from Google Play services. So instead of linking these two SDK, you would link in a very lightweight client library that would let you make a request to Google Play services. Then you will just get it. And we also help you to update the SDKs when a newer version is available, and you don't need to worry about manage the updates. So in summary, the benefits of using TensorFlow Lite with Google Play services is you can get reduced binary size for up to 5 megabytes if you're using both the TensorFlow Lite runtime and GPU delegate. And imagine if there are 10 apps on one device that are all using TensorFlow Lite, you would save a lot of space. You can also get the latest stable version from TensorFlow Lite from Google Play services. You don't need to worry about update those SDKs. It is also the official machine learning inference engine recommended on Android. This effort has gone public this summer, and we already have more than 10K individual apps that is running with TensorFlow Lite with Google Play services. And we have more than 1 billion monthly active users now. And we're building a new product right now. It is called Acceleration Service. It is to the same goal of trying to solve the production issue of machine learning models, machine learning features. Imagine if you have your own model and you want to benchmark it on user's device, whether you can enable certain accelerators, for example, GPU or DSP. And if you give us your model and some sample inputs and the expected result, we can give you the performance report and accuracy result on the fly. And this can run asynchronously. You can start this in your own app, and once you get this result, you can choose to enable or disable a certain delegate. And this is still work in progress, and we're planning to do early access program in January, and we are still taking applicants. If you're interested, please sign up. And if you're interested in more about Android machine learning custom stacks, you can find more on the website. And this is the presentation. Thanks. And for the next part, I will do some live coding to show you if you already have an app that is running with TensorFlow Lite open source SDK, how to move it to the TensorFlow with Google Play services. Here is a sample app that I downloaded from the TensorFlow Lite examples. It is as you can see, currently it is using TensorFlow Lite. Currently it is using Currently, it is using the TensorFlow Lite SDK. And I will show, it is a very simple image classification app with only two classes. And I will show you how it runs. So it runs like this. It would display what the result is on the screen of what this thing is. So it's a very simple implementation with only two classes. And let's first try to change the dependency from open source TF Lite to TF Lite with Google Play services. I will just copy over the new SDKs. As you can see, previously we had the TensorFlow Lite SDK and support library, and it is the same. We will have a Java SDK and also the support SDK. Cool. And then let's take a look at the code. So it has two classes. One is this image classification helper. What it does is it takes care of all the model inference features. It will create a TensorFlow Lite interpreter, and then it would take the input from outside and then try to run inference and then give back the probability of what is on the screen and what's the possibility. And then the other one is the camera activity, which is the main activity. It creates the classification helper and reads the input from the camera and then give it to the classifier, and then later display it on the screen. Cool. And then let's start with the migration. One thing that TensorFlow Lite is a bit different, the TensorFlow Lite with Google Play services is a bit different, is that you will need to request the TensorFlow Lite runtime from Google Play services. And that request is a asynchronous operation. So let's start with that. Let's call it a initialize task. And it is of type task void. And this task is a Google Play Services specific concept used to represent asynchronous operation. And let's take a look at how it looks like. So it gives you some APIs so that you can get notified when the task is canceled, is succeeded, or is completed with these listeners. You can also choose to continue the task if the previous one finished. That would let you to a chain of actions, or you can also execute some code only if the previous task succeeded. So let's define this initialization. The initialization is done from tflite.initialize. And this is coming from the client SDK that we have just switched to, and then it takes a context. So we define this as a value. So when this is used, we will execute this initialization. And we would want to do this initialization as early as possible, and also only do any machine learning action after that initialization has finished. So here we create the classification helper in onCreate immediately, but we would want this to be wait after initialization has finished. So let's call this initialize task first, and then we can add a success listener that would only create this classifier after this has finished successfully. Right now, there's a problem that if this initialization has failed, there's no way for us to know. So it's better if we can add a failure listener here and then do some fallback as you want. Now maybe let's just do a quick logging. And let's log the exception for now. And if you want to do other failure handler, you can switch this to your own preferred way. So now what we have just done is when onCreate is execute, we call this initialize task, which would run tflite.initialize asynchronously. And if that one has failed, we would log it. But if that one has succeeded, we would define this classifier that would help us with the machine learning part. Cool, and that's the initialization step. Let's go to the actual classification. So we might need to do a little bit change with the interpreter. Since we have launched TensorFlow with Google Play services, we have changed interpreter to interpreter API. And you can use that for both TensorFlow Lite runtime. And it's of type interpreter API, and then you would use interpreter API dot option to create that interpreter. And you will also use interpreter API dot create. And the syntax is the same as previous interpreter. So also one benefit of this API is you can select between the TensorFlow Lite with Google Play services or the TensorFlow SDK that you bundled into your own app. If for some reason Google Play services is not available, you can bundle in an open source version so it can make that selection. And that is controlled by this runtime option. You would see three of them. From system only means get the TensorFlow Lite runtime from Google Play services. From application only means load it from your own app. But there's also another that would let you to try from system and then fall back to application if it doesn't work. Let's try with from system only for now. Cool. And then that is everything you need to do to move from open source TensorFlow Lite SDK to TF Lite with Google Play services. And because we have been using the old interpreter way to create it, let's remove this. And I think I have some transient issue with my Android Studio. Okay, now it's finished. Let's try to launch it. Cool. And you can see this app is working now with the new dependency. That means we have successfully migrated to TF Lite with Google Play services. And right now, this model is running on CPU because we didn't try to, we only use the default settings which let you run it on CPU. And let's say if you want this to run on GPU, it's also possible. First, let's deal with dependency. As we mentioned, we have a GPU delegate that would help you to do that. And in order to do that, we would need another lightweight SDKs. It is called TF-Lite-GPU. And now it is synced. Then similarly, we would also have a initialization step and the actual enable. So before, in this initialize task, we just initialize without any settings. If we want to see whether the current device support running machine learning models on GPU or not, we would add a initialization option. And in this option, you can request it to check whether the current device is compatible or not. Then build the option. And in this case, if the GPU delegate is not supported, this initialize would fail. And it's better if you can add another step that would fall back to CPU if GPU is not supported. So let's do a continuous. And you can get the previous result from this task. And you can check whether the previous task is successful or not. If it is successful, then great, we're happy. We can just continue with this task with probably a stakeholder result because we don't need anything and the task is of type void. And if it didn't succeed for some reason, maybe because GPU is not supported on this device, we want to fall back to the previous way of initialize, which is doing initialize again without any options. And now we have successfully initialized it. And maybe let's use another value to store whether. Let's have another Boolean just to store whether was it success or not. So let's put it as false in the beginning. So if it did success, let's store the state and set it to true. And this should be a variable because we would need to change the value. Cool. Now we have successfully initialized, and also we have figured out whether GPU can be used or not. And we don't need to change anything here, but the behavior now is when we call this initialize task, we would first try to initialize with GPU, and if that failed, we would try again with CPU, and if that failed, we would log the error in the end. If that succeeded, then we would come here and then create the classifier. And then let's also tell the classifier of whether GPU was supported or not. I just added another value so that I can pass in that information here. So once that initialization has finished, we want to let the interpreter know that you should run the model on GPU instead of CPU. So that is done by changing the interpreter options. So aside from set the runtime, we can also add a delegate factory. So this is using the delegate API we have previously talked about. It would enable you to move your model from CPU to GPU. Cool. And then that's it. You have successfully moved from CPU to GPU. And then let's try again. Cool, and yeah, this time it built. Okay, and yes, it's still working. Now, it's very hard to tell whether performance have improved or not, because it is close to real time. But if you have a more complicated use case, you can try to benchmark yourself and then see if it is improved or not. And we also have other tools like TF-Lite benchmarking tools and also acceleration service that we're building that is to help you to get insight of whether it is better to run it on GPU than CPU, so that so that you can have that information on the device. And this is a very simple example that I'm using for image classification. And there are also other samples like object detection that would tell you whether it is, that would give you good examples of how to do that with TensorFlow Lite, with Google Play services. And that's it for the coding part. Cool. Then I will be address some questions from the audience. Cool. Yeah, the first question I got is, what are the languages support in TF Lite in Google Play services? As what I showed you, it was using Kotlin, and for Kotlin you can also, and Kotlin is also compatible with Java, so which means it is compatible for both Java and Kotlin. And if some of you might know that we have C and C++, which is also called native APIs available. And if you want to use those APIs, that is not available for TF Lite with Google Play services yet, but we are working on supporting that. So you will also be able to use native APIs. And next question. Next question is, what is the plan of supporting other device hardwares? So currently, as I said, we support GPU and DSP and TPU through GPU and API delegate. So for other hardware devices, we want to have more vendors that to be able to support TensorFlow Lite operators. So we're also building a new product to provide a universal delegate API for them to support this, and then this can extend the hardware acceleration to more device hardwares. And this is our next product building next year. And then next question. So next question is, how do you enable NPU or TPU acceleration? So what I have showed in the coding is you can use GPU through the GPU delegate. There's also another thing called an API delegate that you should be able to enable that through the options. Let me see if I can quickly find it. You can use a add delegate with an API delegate. Yeah, that would be how you would use that delegate, and then you would need to give the accelerator name that you want to use, so you can do that very easily. And the whole effort about delegates is we want to move the model to work on different accelerators as easy as this, so you don't need to think about how to get underlying. And also I forgot to mention that during the initialization step, we will be checking GPU delegate is compatible on the device. And so it can also give you some information of whether you should enable that accelerator or not. Cool. And next question, please. So the next question is anybody using machine learning on mobile, and what are the scenarios? There are a lot of use case that is running on machine learning, that is doing machine learning on mobile. For example, if you have, so for example, like all the image classification, if it's doing real-time classification, and if it's try to do live translate, and those are doing on device, because the latency of doing inference on server and then get the result back, that would cause the latency to be very high. So you might not, so that would make the real-time functionalities not very possible. Yeah, I think that's the scenario that I currently think of. And also, like I mentioned, object detection and question answering, etc. And yeah, the good thing is, even if your device is offline, those functions can still work. Cool. And next question. And the next question is, what are the steps I should take to optimize my TensorFlow model for TF Lite? So if you already have a TensorFlow model and then you want to do the conversion, you might want to take a look at the result of how much latency is the model have and how big the model is after the conversion. Because if it's too big, it might be an issue for putting that into the app. And also hardware compatibility. If you want to use GPU, for example, you can optimize your model towards that direction. There's a optimization toolkit and also guidelines provided on the website to give you suggestions about different techniques. I have mentioned quantization that can help with the model size, and there are also like clustering and pruning that would help you with that. And also, if some of the operators are not supported, then you can refactor your model to use some other operators, or you can find a advanced conversion technique to let you convert those operators. Yeah. And next question is, can I translate to TensorFlow Lite model originally developed with Hugging Face and TF Lite? Yeah, it is similar. So it really depends on what operators are being used. If the Hugging Face operators are not supported with TensorFlow Lite, you might need to do some model refactoring, or write some custom operator yourself. But most of the models should be already working out of the box. And next question is, for clarification, TensorFlow Lite currently only support the two languages, soon C/C++, but not Python. I think so. TensorFlow Lite, it supports Java and Kotlin, and for C and C++, it is supported. However, C and C++ API is not provided through the custom machine learning stack through Android. So if you are using that, you would still need to use the open source TensorFlow Lite SDK. And we are planning to support C and C++ APIs soonish, but that effort is still working in progress. And next question is, how can we use this when we have lots of images in the Android app and the CPU can't handle it? Should we divide it to server, etc.? I'm not really sure what do you mean by you have a lot of images. If you have images that is bundled into your app, then if you have images that is bundled into your app, then that's probably a limitation on the device memory. If you're talking about streamlining the image that you're getting from camera and then put it through the pipeline of inference, then I think that can be supported by CPU. It's just, it might not be what CPU is built for, so you might have a slightly higher latency. And I would recommend you to try use GPU, because GPU sometimes works better for images. And you do have the options to divide the inference to the server side, but then you don't get the benefit of machine learning feature can work without internet connection. And also it might make it might be a problem for real-time processing use case. So my first suggestion is try move it to GPU or TPU, just as some other chips that is available on mobile devices. And if that is still a problem, then try to do it on server side. And then next question, please, is what is the difference in pricing plan? Open source is free, Google Play services, TF Lite is charged. It is not charged, as in you would need to pay. If you can use Google Play services, then you can get TF Lites from Google Play services. I'm not sure if I confused when talk about the cost of serving. Is what I did mention that it would be the benefit of is it can save the cost of doing server-side hosting, because if you have server hosting models, then you need to do the calculation for all the devices that is out there. But then you are not using any of the on-device chips that would probably, and if you have the model that is already bundled into the app, you don't need a server. So that's how you save from the server side, the cost of server side. Cool. And next question is, do I need to enable anything on the GPU side to use TF Lite GPU delegates on my device? Is there a way to check to see it is running on GPU or CPU? So I don't think you need to do anything on the GPU side. And the whole goal of GPU delegate or delegates in general is so that you don't need to do anything towards the GPU, and you don't need to work with those lower level APIs. So if you are checking during the initialization step that it tells you that is supported, then you should be able to use GPU. And is there a way to check to see if it's running on GPU or CPU? I think if once you put that into the delegate factory and then it didn't crash, that should already be working on GPU. On top of my mind, I don't have a quick way of how do you check where your model is running. Yeah, and that's it. I think this is the last question I have. And if you have more questions, you can post it to the TensorFlow forum, and all the Q&A would be posted there after the event. And I just want to thank you all for listening to my talk today. And I would encourage you to try to use TensorFlow Lite with Google Play services. It should be very easy if you already have a TensorFlow Lite running. And if you have any questions or concerns, you can also put that to TensorFlow Lite website, and we will try to help answer those questions. And yeah, and please give us some feedbacks if you are come into problems, or if you feel it can be easier to use. And that's it for my talk. Thank you.